Good afternoon, learners. Let's come to another topic in technical drawing, which is similar figures. Now, when we talk about similar figures, we are looking about figures, two or more figures with the same shape but different in size. For example, they are giving you a pentagon, and before you can draw the similar figure of this pentagon, the answer that you are going to get, it should be the same thing, but either what you are going to, you should look at the same thing, no changes, but it can be small or it can big. That is what we are going to look at. Meaning that similar figures, they can be figures, two or more figures, the same thing but different in in size. And we have methods of similar figures. Let's look at the methods of similar figures. Methods. We have two methods under the similar figures. We have one, reduction. Two, we have enlargement. Now, when we talk about, we are going to pick them one after the other. When we talk about, let's look at reduction. We are starting with reduction. When we talk about reduction, we are talking about figures which look alike, which have the same shape, but they are smaller in size when you compare to the actual figure being given to you, or they have been reduced to the smaller size. For example, if I have maybe this figure, rectangle, and I said that I should draw the reduction form of this rectangle, the smaller size, this is the reduction. But the moment it's become more than the given figure, is not a reduction. It means that you have gone out of the question being given to you. So when you talk about reduction, we are talking about a method, or it's a method of similar figures when the size is smaller than the given figure. Let's look at its construction. Then after that, we will come and look at enlargement. Construction. How do you construct reduction figures? Let's pick one method. We look at it as time goes on. We'll be taking it one after that till we look at most of the method under the reduction. Then we'll move to the enlargement method. Now let's pick this question. Example 1. From one side of the given figure, ratio is equals to 2:3. Base is equal to 30 millimeters. Used it to draw a pentagon. Now, be mindful. Sometimes when they give you like this, Since we have the base, I can choose to pick any of the method under the polygon to construct. I can use the stay and 45 degrees method, I can use the diagonal method, I can use the semicircle method to construct because the base is given to me. Then after that, I can just use, because if you are talking about reduction, then I will look at it. Or the question may frame, construct a pentagon using this method with blah 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 blah. After finish working on it, say that then based on the figure drawn, construct the reduction form using the ratio this from one side of that figure. We have the center one and we have the what from one side. Let's look at those methods. And that one side we also have categories under them. We have two aspects of it. By taking within the one side or taking the outside the one side. Before I can draw the reduction of this figure, unless I construct my pentagon. How do you do that? I can use, we have so many methods that I can use it. So let me use the 45 degrees and 60 degrees method, which is the general method. I have mine, I've taken my rule. I've measured my 30. Now I want to name it A, B, point A, point 1, B, 30 millimeters. Then you can stand on any of the points to construct those angles, which is the 45 degrees and 60 degrees method. To get the 45, unless I construct 90 degrees, you pick your compass and open a convenient radius, as we did in the polygon. Now I'm constructing my 90 degrees. Now I'll finish constructing the 90 degrees. I use the short dashes to represent the 90 degrees because it's not part of the what we want. Now that I'm going to construct the 45 degrees. I open, then draw my arc, stand on the 90, draw my arc. Now I've gotten my 45 degrees. Since I've done 45 here, means that my 60 can go to the other side. If the 60 comes here, the 45 can come at this direction. Now, use the same convenient radius, then construct my 60 degrees. Then I'll stand on 0, then to construct my 60 degrees. Then I will draw my after that, then I'll bisect the line AB into 2. I'll stand on B. so that bisection line will touch or pass through the 45 degrees line and the 60 degrees line. Where it touches the 45 degrees line, I will name it 4. Where it touches the 60 degrees line, I will name it what? 6. Now from there, since I want pentagon, if it is quadrilateral, I'll just stand on 4. If it is hexagon, I'll just stand on 6. Depending on the type of polygon, if I want octagon, I need to stand on 6, measure 4, then I'll cut. Now because I want an odd polygon, I need to divide the 4 and 6 into 2 to get the odd polygon. Okay, I'll open my convenience radius, I bisect. Now I have bisected the 4 and 6. Now I have gotten my 5.5. Now since pentagon has 5 sides, now I can stand on 0.5. If I want 7, I'll just measure 5 and 6 to cut on the vertical line. Depending on the polygon you are construct. This method can construct any polygon of number of size. Can construct 12, 15, 30. The only thing, you just have your 4 and 6. Depending on the number, then you mark upwards till you reach the number of the size of polygon that you want to construct, as we did earlier in a previous topic. Now I'm coming to stand on 0.5 because it's a pentagon. Stand on number 5. Set it to point A and point B so that I can get the correct circle. After that, then you measure the base length given to you. I stand on A. I've marked. Stand on B. I've marked. And I can stand on the next one, and I'll mark. Then do that. I'll get the next point. I'm coming to join them. Then I can name here 1, 2, 3, 4, 5, and 2, 1. The 5 side. I've finished my pentagon. Now that I'm about to tackle the reduction question. It said from one side. It's talking about one side. It's talking about the sides, the vertices. From one side, 1 to 5, 5 to 4, 4 to 3, 3 to 2, 2 to 1. Any of them is a side. And because I want it to be simple for me, I'm using the base area, which is the AB, which is 1 to 5, to do it. Except from one side of the given figure, it means that what you are going to do is that the ratio that you are going to do should be within the side. And it can be outside, or you pick it from the what? The vertex. You can pick it from 1, you can pick it from 2, 3, 4, 5 to do it. Or you can let it fall in between the what? The side. We are going to look at the two aspects of it. I'm doing this one inside. The next time we will extend the baseline, any of the baselines, any of the side lines, to do it outside the what? The line. If I'm using 1 and 2, I can extend the 2, then do it outside. Or I'll extend the 1 and do it outside. If I'm using 1 and 5, which is the AB, I can extend the 1, then I'll do it outside. I can extend the 5, then I'll do it outside. Or 4 and 5, I'll extend the 4, then I'll do it outside. I'll extend the 5, then I'll do it outside. Or I can do it within. Now, let us do within. The next time we look at outside. I can pick my reference either at point 1 or at point 5, or point 2 or point 1, point 2 or point 3, point 3 or point 4, or point 4 and point 5. If I pick 1 and 2, it means that it means that it should fall within the number, the side. I will draw it here, or I'll stand on 1, then I'll draw it. If I'm using 2 and 3, I'll stand on 2, draw my ratio line, division line, but I want to use the base side. So I want to stand on 1. I'll draw my division line. But the ratio being given is 2 is to 3. The highest number is 3. It means that we are going to divide this base, one side of the line, into 3. Into 3. To use the highest number into 3. It is not like when you are doing the division of line, you just combine all of them, then you come and divide it. No, this one is a similar figures, reduction form. You pick the highest ratio, which is the 3, then you divide it. You open your compass at a convenient radius, then stand on your starting point of where you did the division of line. I've marked 1, 2, then I've gotten my third one, 3. Then you join the 3 to the last digits of the side, which is the B, or number 5. Because here is my 1, 2, 3. So I've joined number 3 to B. If I use the B as my division of line reference point, it means that I'll join the last digit to what? To A. Then after that, you pick your set square, place it on the ratio, the highest digit, which is the 3. The ratio being given to us. Then you guide it with a rule. After guiding it with a rule, then you move your set square to the point in which they say the reduction should be. The reduction is 2. If it was 1, move it to 1. But because it is 2, from 3 to 2, 3 to 2, it means that the reduction is what? 2. So you are moving from 3 to what? 2. If it was 1, we'll move it to 1. Now, this is our 2 points. That is where we are taking either 2:3. 2:3. The 2:3. Then, where did you started your division of line from? You started from A or 1. It means that all the rest of the vertices points should join to point 1. If it was at number 5, all of them should come to join to number 5. So now I have 1 here because I started from 1. 1 is my point reference. 2 is already joined. But has 3 joined? No. Then you join the 3 to point 1. Has 4 joined to point 1? No. Then you do that. As 5 joined to point 1, yes, that is the piece. Then after, what you are coming to do is you are coming to extend, because now we have 1 5 line, and this we have 1 4 line, 1 3 line, and 1 2 line. Meaning that now, are you seeing 5 and 4? We will now take the reference at the 2 side. The 4 and 3 will be within this 1 and 4 and 3 line. The 2 and 3 will fall in between the 1 and 2 and 1 and 3 line. So how do you project it? The 1 and 5 is already there. So we just move to. Now I've taken my reference. This is 4 and 5. Stiff my hand on the rule. Now I'll move it to the ratio 2 on the 5 points. And where is the 4 points? This is it. And this is it. I'll just join it. This is the 1 and 5 line, and this is the point 2. 1 and 4 line, this is the point 2. Then I'll come to 4 and 3. I'll place my set square firmly. Then I'll stiff my rule. Then I'll come. Where the 4 ends, I'll come and stand there. Now I have my 1 and 4 line, and this is the point 2. 1 and 3 line, this is the point 2. Then I'll what? Strengths. Then I'll come to my 2 and 3 line. 2 and 3 line. I'll take my reference, guard it with the rule. Then I'll move to where the 3 ends. Then I'll come there. This is where it ends on number 2. And this is the 1 and 2 line. This is where it will end. Then I'll what? I will join it. Now the rest of the, now this is my actual work or question answer that is told me to what, that's the reduction. Then I'll use my H pencil to dip my work. That is the reduction. Have you seen? Now the 0.4 of the 2:3 have moved to here. 0.3 have moved. 0.2 have moved. If it was 1:3, it means that these points will now be around this place. They can combine and say that a ratio of 2:3 and 1:3. It means that you also, after that, you also do for what? 1:3. You will have 3 figures here. That's why the definition said that it is, when we talk about similar figure, we're talking about 2 or more. Here, when you can see 2 figures, what here? The given figure and the reduction what? Figure. Have you seen they look the same thing? But it's different in one side. This is the smaller. Because it's a smaller, we call it what? Reduction. And this is the method that you have done within. And we can do outside. But the same from the what? From the points. To see you another episode of construction of reduction in what? Similar figures. Have a wonderful afternoon. Goodbye. And don't forget to subscribe, like my video. You can join us at YouTube or TikTok or in Facebook, in or other media that you think that you can find ING-NABILA Joan on it, to subscribe and watch and follow us, and we'll give you more constructions under the technical drawing.